Hello everyone, I'm Xiaogam. In this lesson, we'll mainly cover cooldown. The cooldown is actually very simple because like consumption, the engine has already done it for you. The tricky part is that if you want to listen to it, there's a problem. Depending on our synchronization mode, it may not be listenable on the client side, making it impossible to check this cooldown. So we might need to add a layer of indirection. There may be other better methods, but let's write it this way for now. Then let's first implement the cooldown. After that, we'll add the UI listener for this panel. Normally, these skill panels can later be configured by reading tables. You can make all tags completely dynamic. For learning, it's more suitable to write it out first, like this. That way, when you see the code, you know this part is hard-coded. Okay. Then let's prepare a cooldown here. Then we come here. Let's first create a game effect. Find our GameplayEffect. Generally, for a game effect, we don't really customize it like that. Then, we call it cast Cooldown. And how do we write it inside this cooldown? First of all, it is something like a variation, and it is a scalar. Let's give it a 3.0. For this palette, we also give it a 3.0. And as for this part, we don't care about this part, and here we need to select this components. We need to select this one here. We need to select a components. This components, we have to select this one. Grant this tag to this actor. Select this one. We might have selected it before, but this time we need to select grant. Just grant this tag, then add this here. This is the abilities. Give it a target tag. We specifically make a cooldown for it. Cooldown. Then cast it. We only do the cast. We haven't done many ability notifies. We'll just demonstrate a light attack, and the heavy attack's ability notifies. Everyone can go ahead and fill it in themselves. Because of this, writing your tags becomes very troublesome. Once you write too many, it becomes very troublesome because they will conflict with each other. You need to consider the whole. That is, the designer needs to consider what stage your game has, the mutual relationship between tags. We are only responsible for implementation. Now that we have this, then we take this gameplay tag and mount it to this place. There is a cooldown here. We mount it there. We should write it into test. Let me think about it. It should be this one. And if we place it now, you will find that we simply cannot place it. We must force a 3-second wait. You can see this 3 seconds might feel a bit too short. We might not notice it clearly. Let's change it to 10 seconds. Change it to 10 seconds. That works the same way. This might be related to that, because some memory can be triggered periodically. For example, applying a burn effect to someone, and then draining health every second, that kind of thing. You can adjust it inside. This parameter can achieve that. Stacking, periodic triggers, and stacking refreshes. All of these can be done in GS. It's all written in that document. Then this 10 seconds, we'll have to wait a long time. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. We can finally, you see, our 10 seconds took a really long time. We were pressing this key the whole time. Then after we give it 10 seconds, the most important thing now is to listen to it. So we need to listen to it. So where might something like this be placed? So if it were you, first we thought about putting it in game ability. Then we looked around and found that game ability doesn't have it. So we must be looking in the ASC. Because in our ASC, it serves as our entire management capability system. You can see its header file alone has this many lines of code, a lot of code overall. So it acts as an agent. Actually, let's find its cooldown for it. See if we can find it. You can see here, everyone can access it, like how long it has been going on, etc. We are mainly looking for a delegate for this cooldown now. You can see abilities committed cop-outs, abilities failed callbacks, abilities end. Then, which one do we mainly use? We mainly use this one, and then this thing. This delegate, it returns a pointer to a gameplay ability. Such a pointer, such a delegate. And within this gameplay ability, it actually has a function like this. We can see here there is a gamma ability. It gets called down remaining. So this is the function. We can get this function. So how should we do it? You will find that this thing, it is not dynamically multicast. We want this thing to be dynamically multicast. So actually we need to bind this delegate on the ability system component. We make it so that every time it is successfully committed, we pass back this game ability. So let's handle it this way for now. There are definitely many methods. Everyone can try more approaches. In this character place, we prepare a dynamic multicast delegate because we want to do it in Blueprint. I don't want to write another component at the C+ level. That's how we'll handle it because I think it's quite like this. This is a very simple function. Okay, so after we declare such a dynamic multicast delegate here, then it will output here its time and this. Which tag? Exactly. That means the ability has been activated. So here we give it a public. This makes it easier for it to be used publicly. Put it here. Okay. Then this delegate. This is exposed to Blueprint for binding and usage. So this delegate, how should it be done? Then we actually here. When the begin play function is called for this place, this place has one of our own. R2, R2, 2, 2, have a delegate inside the ASC. We are at the very bottom here. When we have completed this ability registration, we get our ASC component. After getting the A4C component, we let it commit these bags. That is, we successfully submitted the ability just now. It will trigger this delegate. We directly write a lambda for it. Write a lambda. We let it do this. Okay, so this lambda, this delegate is inside a 4C. It will only give you a game ability. Then we directly use game ability to get its CooldownTimeRemaining. Then here we get this game abilities tag because our printer needs. That is, our page, we need to know which ability is activated and what its cooldown time is. Then we make an RPC here. Because this part can only be done on the server, because when I build the client, I found that as we might not be able to cannot get this time, the QN_time_remaining parameter, because it might always be 0. This part has issues, so we can only do this part on the server. And then by sending an RPC, now let's write this RPC function. This RPC function is also relatively simple. We put it above it. So it actually just needs to call this delegate. We created implementation. As for this implementation, we need to add a suffix. As for this suffix, we need to write this importation. You can write this word. Sometimes I often misspell it, because when I spell it, I often miss an implied. Okay, then we just need to execute this delegate. Then let's see if there are any compilation errors now. There shouldn't be any. Okay, let's build it. But when you do this binding, actually, if you have a good habit, when you're in the underplay phase, you can also perform the corresponding unbinding, etc. because it's just a good habit. Because we have a good habit, right? Then we can see here. Okay, so we have compiled successfully. Next, we just need to go to the blueprint to bind this delegate. And now we start. Good, we have started. Then we will simply write it here. So we will take up this scanner panel here. Okay, we can directly go to our UMG. Let it inherit from our Gao game. Or give it to our U base. It can inherit from it. We call it VBP scanner panel. Then we also need to prepare a slot here. This is called scanner. Okay, after preparing the slot, 这样的 D. As for this slot, it's actually quite simple. I will copy it over first, just a size box and an overline. Then we just deliver this. This size box, we set it to 100, and these two delivers are its time. One is its position. you need to pay attention. Actually, right here, we can let me take a look. Actually, we can do some binding like this. So how do we do it here? Here we just create two get bindings, and then we also create a binding here. Okay. Alright, so for this part, the first one should be our index. It should be this index. Let's promote it. Let's call it scale index. Actually, this thing will be dynamically generated, but we didn't implement dynamic generation for the panel because we are only making one scale to demonstrate to everyone. Because later when you develop your own projects, you will definitely time. Okay. And here we definitely have a time, a countdown. So we need to use tick to do it. Let's take a look. This part is a prompt. We need this to be instance editable. Expose no blueprint readable. This is checked incorrectly. Okay. We need to update the time in tick. So how should we do this? Actually here, we are inside the tick. We need to add some parameters. First of all, we add a tag first. Should be scan, should be gameplay tag container. Using this is also fine. Then we call it AbilitySystemComponent. Okay, this thing also needs to be exposed. Nozzle needs to be exposed because we need to modify it in its parent container. Then we prepare a cooldown time. As for this time, we also need to expose it. It should be x1. Then, as long as this time is greater than 0, we need to perform an update. For this update, we use a branch to do it. This is a common way we write. If it is less than 0, we set it to 0. If it is greater than 0, we subtract this time per frame, thus creating a feeling of 1 frame of time. Then here we do this cooldown. That's it. We will update every frame. The cooldown time. Okay, so here we need to have a process of setting the cooldown. Let's expose a method here. Let's create a new method for it. Called setCooldown. Okay, here we mainly set this value. We pass it in. Okay, that should do it. Then when we get 0 here, we need to do it this way. We need to convert it to this time because the time of this cooldown is not a text string, right? So this variable, actually we can do without it. This variable is not needed. We just need to change this part. And note, here we set its decimal places to only 1, not too many. Then you can change it to 2 digits. Maximum decimal places, let's change it to 2 digits. Okay, once we have such a panel, this is our slide. Then here we add it on. As for this panel, we better give it a horizontal water-like container. Then we put it here. Then we give it a scale. Slow. Then we give it a desert. Okay, then let's copy it. We won't go with dynamic generation. You can certainly do dynamic generation. That's completely fine. And here, for this index, this model is 0. Set this index to. Set it to 1. More corresponds to our 1234 key. Sang. So, okay, then we'll only do the first one. For the first one, our ability's capability should be this cast. So we give it an ability action. Didn't we give it the cast tag? A task tag should be given here. This side should be low. I happen to see it while working on this. Otherwise, it would really be missing this task tag. Okay, so we have set this up here, and we haven't written the code inside yet. This code is actually quite easy to write. So in this place, we definitely have a player controller here. We get the pawn controls. We cast the pawn to our character base. Then after casting to the base, it has an event. It is an event specifically used to trigger ability submission. down the event to abilities class. Then for this event, we will make it a custom event. Okay, then we must make a judgment on this tag. That is, it must equal our tag. Obviously, we only need to make one judgment because we only plan to write this one. Since it can be obtained, we can judge if they are equal. It proves that we need to update the time. So when it comes over, actually it can get this. So this time is set cooldown. Okay. Okay, here we align this gap. Okay, here we put the judgment here. Good. After getting it, and then we remember, that ability we just had. Seems like when we wrote the ability earlier, we might have missed it. Because this skill is written, I'm a bit dizzy because it has too many configurations. Sometimes you only work up to this point. And only remember this point. You must get this tag, then we are here. When we bind this binding here, we can only get this tag. Otherwise, we won't have it. Okay, now let's test. We need to add it to our main panel. The main panel is here. We add our skill panel into it. Gun panel. We'll just put it here. Its default value. We set to 1.5. Right, that's not important either. Let's take a look. We place a skill. You can see this cooldown is correctly calculated in response. Right, it's completely fine. No issues. This part is, why do we have to go through the server for this? Because I found that this thing on the client side is 0. The cool time it provides is not obtained. It hasn't correctly retrieved this time. Why hasn't it correctly retrieved this time? It's because the X tag on your client side may not have been synced over. So we can run a test. Let's check if this time is accurate. Come here. Let's change the time for our deduction to 5 seconds. 10 seconds is way too long. After changing it to 5 seconds, let's release it. Let's play it. You can see, it's indeed 5 seconds, right? There's no problem at all. It's indeed 5 seconds. After 5 seconds, it can be released again. Okay, so our cooldown is done. And why is it like this? Why do we do this RPC? I've explained to you. I just didn't go into enough detail. Let's look at the underlying layer. It's instant. Then get cooldown. If it is, we go into this. After walking in, you will actually find it does it this way. It gets this cooldown tag. After getting this tag, it sorts here. Anyway, it just takes a time and gives it to you here. Then you will find that is right here on the server. On the client, you cannot get this tag. This qual tag, that is to say you did not get a valid tag. So you cannot match to when you are on the client side. This praise always returns 0. So on our end, we went through the server. This is related to its ASC, synchronization rules. If you are interested, you can study it in depth. Okay, anyway, our consumption has been implemented. And it was quite easy. Because you only need to send one RPC to complete it. Okay, thank you everyone.